Hi, we'll wait for 2 to 3 more minutes just to see if anyone joins and then I'll start the class.
Sure, Silaj.
Okay, good evening everyone. I'll start the class for today. If people are joining, let them join. So, so welcome everyone to the next tutorial. So, there's a seventh week, I guess, right? Yeah, so for the seventh week tutorial, welcome everyone. So this week also we'll be seeing few of the mechanisms. So, all are kinetic limited. We assume there is no mass transfer effect, and kinetics is what playing the major role. And based on that, we are doing uh, the mechanism study. Okay, so I had asked sir if I can discuss the assignment question. So he said that's okay, no problem. So apart from giving a few extra questions and discussing what's taken in the previous week, I'll try to solve the questions of different weeks side by side. So for this week, I'm planning to solve the questions from week 6 and week 3. So week 6 is more of numericals and week 3 is kind of a theory. So I'll do something like that, a mix of both, and like that I'll try to discuss a few of the important questions from the numericals. So I hope that will be helpful to everyone. Yeah, so so I'll start with the assignment questions. I hope my slides are visible. Can anyone just confirm?
Yes, it is visible.
Okay, thank you. So, yes, so the first question is The P solution giving solution directly, and beside that, there is another adsorbed intermediate that is playing a role. So we all know this is a kind of mechanism where any impurities are also affecting our main reaction. So it's an example for such a kind of reaction. So the question says, so this is from the last week assignment. So the question, it has given the, so I'll read the question once again. Consider the reaction P solution giving Q solution plus an electron is released. Then A solution minus, it's a reversible reaction, and K2 is a constant, and it forms an A adsorbed and an electron is released. So the first question is, the kinetic parameters are given by K1 0 equal to 10 to the power minus 5 centimeter per second, B1 equal to 20 volt inverse, K2 0 equal to 10 to the power minus 6 centimeter per second, B2 equal to 20 volt inverse, K negative, K of the rate constant for the backward reaction of the second step is 10 to the power minus 6 moles per centimeter square per second, and for that same thing the B value is given as negative 18 volt inverse, and the total number of sites are given by 10 to the power minus 8 moles per centimeter square. The solution species concentration of P solution, Q solution and A solution minus are equal, and that's equal to 100 millimolar, and it has given the conversion between 1 mole and the moles per centimeter cube. So we are at, if we are applying a DC potential of 0.25 volt versus OCP, what is the fractional coverage of the A adsorbed? Is a question. So if everyone can start doing it, it will be helpful. Like then it will be easier to discuss. So it's like basically everyone I told they want to see how it is solved. So it will be helpful from your part also if you start doing. So if any mistake is made, we can understand that and solve together. Okay, I'll give you a couple of minutes. Please start doing. So I hope everyone understands what has to be done. So you're supposed to find the theta SS, that is the fractional surface coverage at steady state. So you all know what is the first step. You're supposed to write the side balance. So how do you write the side balance? Something like gamma d theta by dt equal to, you're supposed to give the side balance based on the reactions which involve the sites involved. Please do it. If you have any doubt, please do ask me. If anyone has any doubt in the way to approach, please let me know so that I can help you.
It would be K1 1 minus theta, then would it be plus K2 1 minus theta or minus K2? The next one would be.
Okay. So here what we are doing, okay. So what we are doing, we are writing the side balance. So side balance of what? The intermediate species. So the first step is to identify which is the intermediate species. Can anyone tell which is the intermediate species? So here P solution is directly becoming Q solution. Okay, so that is a main step involved, and so this example has been already shown. So this is a mechanism where your main reaction is P solution. It's on the surface it becomes Q solution. But what is happening? There is some impurity in the solution which is getting deposited on the surface of the electrode and becoming A adsorbed, and thereby blocking the active area available for the conversion of P solution to Q solution. Right? I hope that is clear. Okay.
Yes.
So, yeah. So which is the intermediate here? So P solution is something which is in the solution, Q solution is in the solution, A solution is another ion in the solution. So which is the intermediate here? See here the intermediate corresponds to, apart from all the species which are there, like if you are doing some analysis, you will be able to detect P solution, Q solution. Basically, those are all present in the solution. A solution minus, that is also another ion that is present in the solution. What about A adsorbed?
Yes,
Is the
A adsorbed.
is it
That will be
some?
there on the surface.
Yes, it is an intermediate. Something that is getting
Yes.
absorbed, it's getting converted. It's not something which is can be easily detected. So P solution, Q solution, and all are something that's present in the solution. A solution minus is also another ion. So here the adsorbed corresponds to some intermediate. So in any reaction, if it is given as adsorbed in EIS, that means it's it's an intermediate. So here you have identified the intermediate. So we are doing the side balance for some species which we are not able to directly measure. Okay, so here that intermediate is A adsorbed. Okay, that's the first thing. So you have identified the intermediate which is involved. Now the next question is, once you have identified the intermediate, the next question is how much is that intermediate present, or how much is that intermediate blocking the electrode surface. Okay, so for that we are writing the side balance. Okay, so side balance is something done only for the intermediates that are present. So when we are doing the side balance, we will only consider those reaction steps in which the A adsorbed is either formed or consumed. Is that clear? So what I mean is,
Yes, it is clear.
so how will it be? Gamma d theta by dt equal to, if this is R1,
K1,
this R2 and R minus 2. Can someone tell me? Backward reaction will have R minus 2 as the rate. Or you can say in terms of K1, K2, K minus 2. Anyone?
R1 will be K1 e raised to B1.
Ah, okay. So someone tell me K1. So someone was saying something. Gamma d theta by dt equal to, someone was telling the some in terms of K1, 1 minus theta, etc. You can tell. No problem. Okay, anyone, please go ahead. Please tell me. So someone is asking me how to identify whether it is plus or minus.
Yes. Whether it is
Oh,
plus K2 or minus K2, then next one is of say minus 2
okay.
also. Before that it would be
Okay.
plus or minus. How can we decide?
Yeah, I'll explain that. I'll just write this. Someone please tell me if this is correct or not. Anyone? Is this correct or not?
No, in 1 minus theta is not coming with K2. Oh,
It's
K2.
K2 1 minus
Okay.
theta.
Okay.
I think it is correct.
Okay.
K2.
Okay. So what does theta corresponds to?
The surface which is blocked by A adsorbed.
Yeah, the surface which is blocked by A adsorbed, right? So my question is, so when we are writing, so even if everyone is from some electrochemistry background or even sometimes from chemical engineering and all, or anything, when we write mass balance, what do we write? Something is like rate of input minus rate of output plus or minus generation or disappearance. Something like that we write, right? So same thing is happening here. It is the same thing. Like here theta is something corresponding to the fraction of site where A adsorbed is occupied. right? So we give so fraction of sites which are occupied by A adsorbed is what is theta. So that means those reaction steps in which A adsorbed is formed, or when A adsorbed is formed, that is, if you see in this second step, okay, this step you see A solution gives A adsorbed. So the forward reaction corresponds to something where A adsorbed is formed, and theta is nothing but this adsorption of A adsorbed on the surface. So for all the reactions where A adsorbed is formed, we will give positive. Okay, and if you see the backward reaction, A adsorbed giving A solution minus, that is A adsorbed is getting consumed. So backward reaction is somewhere A adsorbed is consumed. That means the theta is reducing. Fraction of sites which are occupied by A adsorbed is reducing. That is why for backward reaction we are giving negative. So one doubt is clear. Someone had asked me.
Yes.
Okay. Now the question is this equation correct? So as someone has told, so you know what theta is. Theta is just the fraction of sites which are occupied by the adsorbed intermediate. So my question is, so I told if A adsorbed is formed, you give a positive rate, and if it is consumed, we give a negative rate. Now the question is, see this part. So this comes from the first reaction step. So in this reaction, that is P solution gives Q solution. Is there A adsorbed formed or consumed?
No.
So how can we account for that?
Yes.
This part is not needed. So
Yes.
theta is something which is the fraction of sites that are adsorbed, or fraction of sites which are occupied by A adsorbed. And if A adsorbed is formed in the reaction, we give positive, and if A adsorbed is consumed, here in the case the negative reaction, we will give negative. Okay, so the first step is to write this without any mistake, the plus or minus, and to consider which all steps should be very clear. So once you write this, now the next step is to find out theta SS. So theta SS is the case where it's at steady state. We're trying to find out if the reactions are balanced, how much is the sites that are occupied by the adsorbed intermediate. So if we have to find theta SS, what we'll do? We'll equate this to 0. Can
d theta by
someone?
dt is 0.
Yes. So this entire equation expression should be equal to 0. So can someone tell what is theta SS then?
Is K2 EDS upon K2 ds plus K minus 2 ds.
Yeah, don't forget the solution term. A solution is also here at the
A2.
top.
Yes.
Okay,
A2 is
don't, because these values are small, if you forget, and it all has a 10 to the power minus some power. So if you forget any of those, your answer will be totally wrong. So this will be K2 DC because it's at steady state, K2 DC. This is also DC. So I hope all of you has got this equation. Any doubt in the equation? So this is the equation. Now the question is, you're supposed to find out K2, sorry, theta 2 SS. So you should know all the parameters. So the first one is K2 DC. So you know KDC. How is KDC related? The formula for KDC?
K10 e raised to the power B1 E DC.
Yeah. So there is a formula. Everyone knows the formula. So there's something direct. You know all everything. You have to substitute. So let's start with each one. So first one is K2 DC, which will be nothing but K20 exponential B2 should be EDC. Yes, so K20 is nothing but 10 to the power minus 6 centimeter per second. Okay. And it will be nothing but exponential of B2. B2 is 20. And you're supposed to find it out at 0.25. What is K2 DC? Please do, I'll also do. Yes, what is K2 DC?
One 1.48 into 10 to the power minus 4.
Yes. It will be centimeter per second.
Minus
Okay.
6. Yeah, 1.4.
Okay.
Right. Right.
Okay, 10 to the power minus 5 centimeters plus per second. Units are important because sometimes you'll have to do some conversion. So now the next one is you have found K2 DC. Now you want to find minus K of the backward reaction minus 2 DC. Again, okay, same formula. So where,
Excuse me, here 10
yeah,
to the power minus 6
hmm.
exponential raised to 20 plus 0.25. So we
20
have to
into
do e raised to
2.25.
20, 20 into.
Huh.
Acha, so 20 into means it 1 by 4, so it is 5. Means
Huh. Yes,
e to
it
the
is
power
10 to the
5.
power minus 6 into exponential raised to 5. It is B2 into EDC.
Yes.
This is the bracket. So raised to. Yes, so what is K to the power minus 2? K for the backward reaction? Can anyone tell?
1.48 into
Hmm.
10 to the power minus 8.
Minus? Sorry, I couldn't hear.
Minus 8.
Yeah, yeah. So I'm getting
Minus
out.
8.
Yeah, yeah, correct, correct. That's correct. So I was getting minus 1.11. That's okay. You told some 1.2 or something, right? That's okay, I think. Okay, so K2 DC we found out, K minus 2 DC also we found out. Yeah, I'll write down once. Now what? Next thing is, so we found out K2 DC, K minus 2 DC. A solution is what? A solution is nothing but 100 millimolar. So, okay. Uh, I'll just okay. So next one is the solution value. So A solution is given as 100 millimolar. Okay, but we know it's everything unit is in centimeter cube. Okay, like centimeter per second. That's how we have written K value. So here it is more 100 millimolar, right? 100 millimolar is nothing but 0.1 molar, right? Correct. There's nothing but milli means 10 to the power minus 3. So this will be 100 0.1 molar. Now if you see everything else is in what to say here, if this is this centimeter per second, this value is also centimeter per second. So basically it is in the units of centimeter. You cannot write something in meter. Molar is nothing but moles per meter cube. So we cannot use that. Instead, I have to convert this meter cube into, 1 mole is moles per liter. So I have to convert it into centimeter cube, and it's given in the question that 1 molar equal to 10 to the power minus 3 moles per centimeter cube. So this will be nothing but 0.1 into 10 to the power minus 3 moles per centimeter cube. So now everyone please substitute all the values. We have all the values and try to find the theta value. Okay, I'll also meanwhile do. So the formula is here. There's the formula we have to use. Theta SS. Anyone got any answer? Did anyone post any question or something? I could hear some notification kind. Or was it someone exiting? I'm audible, right?
Yes, yes.
Yeah, sure.
Yes,
Thanks.
yes.
Okay. Yeah,
So answer
Huh.
is 0.57.
Yes, correct. It's around 0.57. So what you have to do, you have to substitute everything. So it will be, if I'm writing the final form, it will be nothing but 1.48. For everyone, just if in case anyone doesn't get, it is 1.48. Now it's so basically you will make mistake when you are substituting, because if you see all the terms have some kind of 10 to the power, and once if it comes in denominator and if you don't do it properly, there are chances that you will make a mistake. So please be careful. It's always better that you do each step separately and then substitute so that you won't make much mistake. And you should take extra care when you're going for the final exam because you will be having the scientific, I'm sorry, what to say that the calculator which will be used in PC. So that's kind of difficult. So instead of feeding everything together, it's better do step by step. So when you're doing the revision also, it will be easy for you. In case you've made any mistake, you can find it out easily. So you're supposed to get something of this form. Okay, and finally, the answer that you get, I'm sure you know what range is acceptable. So in this question, I'm getting 0.572. Okay, any doubt in this question for anyone? Is there any doubt for anyone? Okay, if no one has any doubt, we'll move to the next question. At the same potential, what is the total Faraday current in milliamps per centimeter square? Okay, so now the question is, you have to tell me what's the IF. How will you write the equation? Who will tell me? I hope everyone can see the question. Otherwise, I'll write once again. It is P solution giving Q solution plus E minus. Who can tell me what is the IF? Please tell the equation. The first step is obviously in writing it without the mistake. Like if it is positive or negative or anything, you have to write that. Only then substitution finding the answer is important. If you make any mistake in giving any plus or minus, your entire answer will go wrong. Who can tell me what is IF, the Faraday current?
Ma'am, IF is F
Hmm.
P solution
P solution
1 minus theta
hmm.
plus
Hmm. Plus correct.
K2
Hmm.
K2
Hmm.
A solution
Hmm.
1 minus theta
Hmm.
minus
Hmm.
K2
Hmm.
K minus 2
Hmm.
into theta.
Yes, correct. So this absolutely correct. So here when you are writing positive or negative, doubt shouldn't come. For forward reaction, it is always positive, and for backward reaction, you will put negative rate when you are writing IF. So only thing you have to keep in mind is when we are writing IF, the Faraday current, we will account only for the electrochemical step. So make sure to just check if there is any electron transfer happening in those steps. If in case there was no electron transfer happening in one of the steps, that step won't be taken for writing IF value. That is the only thing you have to keep in mind. Okay, I hope that point is clear. So you know what is K2 right? You know what is K2, you know what is K minus 2. P solution is known. Theta also. Basically, the thing is, if you make your first question wrong, then this part is also wrong. Because all these questions are like continuation. So if your first question theta value you get is a wrong value, you would have obviously made mistake in this part also. So please be careful. So here this value we found it as 0.572, right? Now A solution and everything we know it is 0.1 into 10 to the power minus 3. We already calculated all these value in for the previous question. Now K2 is 1.48 into 10 to the power minus 4. Centimeter per second. Units are very important or else we may end up making mistake. K minus 2 is 1.11 into 10 to the power minus 8. So now what is K1? Can anyone tell me what is K1? What is K10? K10 is 10 to the power minus 5. Exponential of B1 20 into 0.25. Now the thing is you have to substitute all the value and find out so what is K1? 10 to the power minus 5. I will also do the calculation once again before saying the final answer. Exponential of 20 into 0.25. So it's 1.48 into 10 to the power minus 3. Please substitute. Tell me what do you get? Anyone got any answer?
Zero point 0061.
0.
6.3.
Okay, so everyone is getting 0.0061.
61.
Okay. So have you checked the scores would have been updated, right? Did you after submitting the assignment, did you go back and check how much you got? And also the answers will be given.
Yeah, but ma'am, solution is not provided, right?
But once it's graded, you just check it again, you can see the solution. Can anyone check if you are able to see the solution or not? There's a final answer. No one is able to see because though I'm a TA, I have enrolled for this course and I'm able to see the answers. This assignment is graded, right?
Yes.
So are you able to see the final answer, correct answer?
Yes.
So what is the actual answer?
Actual answer. Yeah. Let me.
Is 6 to 6.3.
6 to 6.3.
6 to 6.3. So everyone has got some answer, but you see there is some issue with the 10 to the power minus 3, right? The answer is 6 to 6.3, but you are getting something like 6.1 into 10 to the power minus 3. So it is a mistake of 10 to the power minus 3 that everyone has made. Now where did this come? Okay, I'll just finish.
They are asking milliampere, right?
Yeah,
Per
so
centimeter.
milliamps. Okay, so where you
Yes.
have to make the
That's right.
change?
That is correct. I make that.
Okay, so where is that mistake coming from?
No mistake.
No, okay, so
Actually, this
you
is ampere per centimeter square. If we are giving in milliampere, then we will multiply 10 to the power 3, so 6.1.
okay, so what mistake everyone is doing is, okay, this Faraday's constant, everyone is taking it. So this is what I wanted to specify on. So everyone, so all these values you can directly substitute. Okay, you'll get something like 0.0061. So please complete. So anyone who is having any doubt in substitution? If you substitute all the values you are supposed to get, but if you make a mistake, you will get 0.0061 or something. Why? So this Faraday's constant is 96,485 coulombs per mole. Okay. So coulombs is nothing but ampere into second, right? There is nothing but ampere second per mole. Am I correct? So you are asked to find it out in milliamps per centimeter square. So if you are taking 96,485 directly, you are not converting it to coulomb should be converted to milliamps second per mole, because coulomb is ampere second per mole. But here this ampere, you want it in milliamps per centimeter square. So the F value that you should be used should be multiplied with 10 to the power minus 3. Because you all saw the answers, you were like, it's correct. You just have to multiply with 10 to the power minus 3. Your answer is correct. But in case if you wouldn't have got the solution and if you were doing, you will not think about it. So understand 96,485 coulombs per mole. You have to multiply it with 10 to the power minus 3 so that you're converting into milliamps second per mole. Am I clear with that?
Yes.
So that is a mistake that people will make. So if I got over here around 6.12 milliamps per centimeter square. Anyone has any doubt in substitution or something? It's clear, right? I didn't write
The
the full.
last one minus minus theta.
So
1.11
yeah, you have to write. I did not complete it.
0.572.
Yeah. So this you have to complete. Here you will have 1.572. That term will come. Then you will also have this 0.572 minus, you have one more term k minus 2, which is 1.11 into 10 to the power minus 8 into theta is 0.572. Is that clear? Okay, if you substitute that, you will get something of this form. Okay. So the next question is, at the same DC potential, the EIS data is acquired using a small amplitude perturbation. What is the charge transfer coefficient? Charge transfer resistance. So how will you do?
That I need to understand. It's my wrong question.
Okay. So here the first step is you have to know what is the impedance equation. So we have already solved it. So if I am again going to solve it, it will take the whole class, because you know what all you'll find out theta SS, then you'll again find it out with AC current, then you have to substitute for d theta by dE. Everything you do, you will get a final expression. So here I am directly writing the expression. So if you go to our week 6 tutorial, we have done this, or even sir's class. So where the equation is this YF equal to F into V1.
Ma'am,
So
I have one doubt actually.
yeah,
If we are solving this equation in exam, it will take almost more than 1 hour.
yeah.
Should I remember this equation?
Uh, like if you are if you do many questions, you should be you will have enough speed, and I'm not sure. You don't have to learn this by heart. You need to know. You will anyway take some 10-15 minutes. I agree to that. I'm not sure. You can just post in the discussion forum and ask sir. Will can you expect such questions? I'm sure that if question paper is prepared, sir will keep in mind that you people will be having only, I think, 3 hours or something, right? So based on that only the question paper should be prepared. That's how sir will do. But still, if you are doubtful, you can just post as a question in discussion forum. So sir will answer that. Okay?
Okay,
Because
thank you.
he'll be the one who is preparing the exam paper, right? So for assignment means you have a whole week, right? So that's why might be. So I'll write the entire equation first. So this equation is little lengthy. Let me write that down. This K2DC, and this particular term is multiplied by yeah. So this is the entire equation. Okay, so it's little lengthy. So we had already solved it in the last class. So I'm just writing it down. So there's a formula. J omega gamma. Okay. So this is the equation for the admittance. So now the question is, what is a charge transfer resistance? So charge transfer resistance is something who can tell me what is the condition? RCT equal to ZF when omega tends to
Infinity.
infinity or zero? It's zero. Okay. If it's infinity, it is polarization resistance. Okay. So RCT is when the impedance turns when omega tends to zero. So this is YF. So 1 by YF is nothing but ZF, right? So this everything 1 by this whole thing you have written F into everything. That once you find out, you have to take the inverse and J omega gamma. So omega tends to 0. That means this term will go to 0. So basically you have to substitute everything and take the inverse. What you get is RCT. Is that clear? That is RCT is when ZF of at omega tends to 0. So I wrote the YF equation, the admittance form. So I told if I am taking the inverse of the admittance, that is this entire equation when inverse is taken 1 by this everything is your impedance, and because omega tends to 0, this term will turn to 0, the everything else. So now what you have to do is patiently substitute each and every value and try to tell me, please tell me what you will get. I'll give you a couple of minutes. Please try doing.
We have to also substitute the value of Faraday constant.
Yeah.
I have one doubt, ma'am.
Yeah.
Faraday constant is not given in the problem. So we should remember that, right?
Yeah, you should.
So 6.85
Okay. I'll just substitute once again so that
ohm centimeter.
yes, correct. I is everyone able to get, or else I'll substitute.
Yeah.
Please substitute.
Okay. Okay, it will take some time. Please try side by side so that it will be easy. Like you can come after you try, you can compare with mine. So in case you make any mistake, you will be able to identify that and stop yourself from losing marks in the next exam. So I had already solved it. So I'm just looking into that and writing the values. If you have any doubt, please stop me.
The value of K2DC is 1.48 into 10 to the power minus 4, or you have written 148.41 into 10 to the power minus 5. What is that?
I did not get
But
it.
we have done 1.4.
Yeah. So yeah, if you see, I have written this K1 into minus K1 DC. Yeah, right. What I've written is correct, right? Which one you're telling? Can you just tell me? Where is it? 20 into 1. So 20 is B1.
1 point K2DC, the value of K2DC is 1.48 into 10 to the power minus 4.
Yeah.
But you have written 148.41 into 10 to the power minus 5.
Yeah, that is K1 DC, right? Here it is B1
Okay.
K1 DC into. Okay.
Okay.
So this one B1 K1 DC P solution into 1 minus theta SS. This much. This full is the first term.
Yes.
Okay. So now what I am writing is
Okay.
B2 K negative 2 DC A solution minus 1 minus theta SS. Okay.
Okay.
Okay. Now the third term, that is minus of B negative 2 K2 DC into theta SS. So it is negative B minus 2, that is minus 18. So minus of minus will become positive. Into theta SS. So that is 0.572. So I have written the third term. Now the next one is the bracket minus of K1 DC, that is again so if you have any substitution doubt in what I substituted, please ask me. So there's that second last term in which there are two brackets, right? So the first bracket I'm writing. You have 3 terms inside the bracket in this one, that is again one more. Ten to the power minus 6. Okay, again there is one more bracket. With something like bracket, you are adding many things. Are you able to get some? Is there any mistake in what I wrote? So this little lengthy. So as someone told, it will take time. So yes, the practice is the only way, and hope such questions do not. I mean, such tough questions or lengthy ones. I hope it won't come. Okay. So and because it is the what to say, the other calculator, you should be careful because there are 10 to the power minus 6 somewhere, minus 4 somewhere. Okay, this how you have to substitute. Then you have to simplify. So what is everyone getting? So someone told? Anyone else?
$6.85.
Yeah, correct. Someone else, anyone got? So I was getting 6.7 when I did. That's also acceptable. Any doubt? Any doubt? So I hope everyone is getting. So I've done it correct. Okay. Now the next question. So RP also the same way you'll have to do. Okay. Now if it is RCT or RP, same way. Okay. Now the next one is yes. So we finished the numerical part. So I hope this has given you an insight on how to do the numerical part. Yeah. So yeah. So this week I've I've started doing week 6 questions. Next week probably I'll do some other assignments also. So side by side I'll do the assignment questions as well as give you a brief insight on what was taught in that week. So that will make things easier for you. I hope that's okay. So now the next question is polarization plot of an electrochemical system is given below. Okay. And it says if the impedance is, spectrum is acquired at EDC equal to the DC potential equal to 0.7 volt versus OCP, what is the expected polarization resistance? So the options are either negative, positive, it can be positive or negative. Everyone knows why?
It would be negative because its slope is inclined.
Yeah.
Uh,
Yeah, so
towards
because so you can see the slope is like in this region where the differential impedance is negative. So because of that, you're supposed to have a negative value. Now same thing, the polarization curve is given, and now what will be the impedance spectrum if EDC equal to 1.2 volt versus OCP?
be positive because it's inclined oppositely.
Yeah, so 1.2 is somewhere here, it will come, and here you can see it's started to rise. So if you take the differential impedance over here, it's going to be positive value, slope is positive, so the impedance is also positive. Okay, now the next one. So another equation is given, and you're supposed to write the Faraday. So it is like it's a three-step reaction where M gives M adsorb plus one electrode, M adsorb plus becomes M adsorb 2 plus electron, M adsorb plus is again giving M solution 2 plus. What is the Faraday impedance?
Third option.
Third option. Okay.
K1 1 minus theta 1 plus theta 2 plus K2 theta 1.
Okay. Anyone else has any answer?
Third one.
Okay, why? So for if anyone doesn't understand that, I told you when you're writing the Faraday current expression, the first thing to check is those expressions which are having an electron transfer involved. Those steps are considered as the electrochemical step, and with the ones without any electron transfer, it is just a chemical step. So if current has to pass through, there should be some electron transfer happening. So you can see this one, and this step is corresponding to electron transfer. So this is involved in Faraday current. Now, if you see the number of intermediate, you have MHOP plus as the first intermediate, MHOP 2 plus as the second intermediate. So, now if I say theta 1 corresponds to fraction of sites occupied by MHOP plus and MHOP 2 plus occupies theta 2, I can say Faraday current is nothing but K1 into M is nothing but will be fraction of sites which are not occupied by the adsorbed species, something like 1 minus theta 1 minus theta 2, okay, plus K2. In the second step it is M adsorb plus, so it is K2 theta 1 equal to IF. Third step won't be contributing to current. So that's why this option is the correct answer.
In which case it would be minus K2 theta 1, fourth option. In which case can it happen?
Yes, it will happen if it is a reversible step. So if I had something of the form like this, okay, I'm giving you an example. It will be K minus 2. Okay, in this case, along with this one, okay, you will have minus K minus 2 theta 2. Basically, you are writing the rate of the reaction, right? So, rate forward is considered positive and backward reaction is considered negative. Is that clear?
Right, clear.
So, if you had a
confused in third and fourth option only. First two options are not that is damn sure, but we are confused in third and fourth only. So that is clear.
So only if reversible step, something is happening in the backward direction, we can take that as negative. Okay.
Okay.
In the same reaction, M giving K1, sorry, M giving M adsorb plus 1 electron is involved. Then M adsorb plus giving K2, M adsorb 2 plus electron, and this M adsorb plus is again getting converted to M solution 2 plus in the third step. Okay, the Faraday current we already saw. This part is already seen. I just copied from the other one. In the above mechanism, how many intermediate species are present?
two intermediate spaces.
Yes, so you can see MH of plus is there, MH of 2 plus are there. So those two are the intermediates. So there are two intermediates which are involved. Okay. Now the next one is, in the above mechanism, in the kinetics limited region, the maximum number of loops that one can expect in complex plane plot is
One more than this intermediate step, that is 2 plus 1, 3.
okay. Does anyone have any doubt in that? I'll still explain. So the number of loops, okay, is equal to, okay, so when you're having any loops, you can say you have, for sure, you have MH of plus and MH of plus. MH of plus and MH of 2 plus. So two loops are for sure. Okay. So based on number of intermediates, you will have those many number of loops. Plus, these intermediates are giving you what? Faradic impedance, right? Now, apart from that, you also have a double layer formation. The first loop will be corresponding to the double layer formation. So, always there will be number of intermediates plus 1. So, if you do this, sometime with what intermediates will give you something, and at a high frequency, you can expect another loop which is corresponding to the double layer formation. At high frequency regime, the loop corresponds to the CDL formation, the double layer, CDL and resistor in parallel. So, total number of loops in this case will be maximum which you can expect is 3. Okay. In the above mechanism, how many DC potentials should impedance spectra be taken so that the kinetic parameters can be estimated with some confidence? Any answer?
Here, what do you mean by with same confidence means? What is the meaning of that terminology? With some confidence.
Okay, so if I am explaining, you can get the data from by modeling, or you can also get the data from the impedance, right? Sorry, so what I meant is you can either model the data using using kinetic parameters. Okay, one side you can do kinetic parameters. Another way is fitting the model. So fit the model means using equivalent circuit model. Okay, so both the ways are equally correct. Now what is the difference? When you are doing it at different DC potential, so we had already seen. So if you get something like this, and if you change the DC potential, you will get some other impedance spectra like this, right? So when your impedance spectra is taken at different potential, you will have different loops. That means the parameters such as what to say, the R, C, all these values keeps changing. So this I'm explaining it with a mix of what is taught in week 7 also. So you have a set of kinetic parameters. I mean, if you're modeling it in the sense, you see, you model and you got some equation like this. So where K1 DC is a function of potential, K minus 2 is a function of potential. So basically, irrespective of what is the potential at which data is taken, you can use this model to fit what to say, this particular equations with this set of parameters can be used to model any set of data, I mean this data at any potential. Are you getting the difference? That is, if you are predicting a mechanism, so mechanism you solve, you get an expression for IF or you get an expression for ZF, you get it as a function of B, K, then concentration, etc. Where this K value itself is a function of the potential. So even if you change the potential, you need not have to derive another set of expression. The expression remains the same for the given model, right? So you need a lesser number of parameters to fit a model using a mechanism. But on the contrary, if you are trying to fit it using the equivalent circuit model, as I told, when you change the potential, the fit is changing. So when the fit changes, that means your R value changes, C value changes, everything changes. So basically what is told is, when you're trying to fit, okay, to a circuit model, the number of parameters from a fit model should be greater than or equal to that from a kinetic parameter. Okay, so here if you see in this mechanism, so how many DC potential? This is the mechanism, right? So tell me how many kinetic parameters are involved in this? Kinetic parameters in the sense from the model. How many kinetic parameters you need to find out when you're trying to solve this model, when you optimize it? You will have one K1, right? So K1 is so because it is an electrochemical step, you will have K1 0 and you will also have B1, right? Now see the next step, it's also an electrochemical step. So you have K2 0 and you have B2. Third step is a chemical step, so that means you need to have only K3, it's a constant, it is not dependent upon the potential. And you have a total number of vacant site. So these are the parameters you need to find out if you are using a model based approach. Now you are going to fit it using a circuit model. So you told there will be 3 loops. Okay, so here yeah, so we are talking about Faraday impedance, right? So this one will go. So you will have only 2 loops, right? 2 loops coming from the this impedance. This one is from the double layer formation. So we are trying to fit it. So we are talking about the impedance fitting. So here you have 2 loops. So each loop will have one R and C, like that 2 loops. So you will have 2 into 2. Plus, if you remember, 2 Maxwell element is needed. Plus, you will have a resistor. How will this model come? It will be something like this. This is the Faraday impedance part. This R into C corresponds to time constant of 2 loops and you have a resistor. So 2 into 2 plus 1. This from the equivalent circuit model. So you have 2 to the 4, 5. So here you have 1, 2, 3, 4, 5, 6. So I told you when you're trying to fit it should be always like the kinetic parameter should be greater than or equal. When you're trying to model this, it should be such that the parameters you get from the fit model should be greater than or equal to kinetic parameters. So if I am going for one at one potential, I need one at potential 1. I have 6 kinetic parameters and I have 5 from the equivalent circuit model. Now I am going for another potential. So here you can see this greater. As I told, this one, that is the fit parameter should be greater. So here it is less. Now if I am going for another one, E2, I am taking the data at 2 potentials. What will happen? I will still have 6 kinetic parameters, but I will have 10 fit parameters. So now this greater than the kinetic parameters. So by this I can say I need two DC potentials in order to estimate the kinetic parameters with some confidence. Okay.
Okay. And the loop depends on the absorbed intermediate, or it depends on the kinetic parameters, or
see, the impedance that you get is dependent upon the potential you apply. So if you are changing the potential, you will get a different loop. But when it comes to kinetic parameters, which is based on a mechanism you are proposing, the parameters used, the rate constant is already a function of potential. So you need not have to change the model or something. Even if at any potential you get, you should get the same you're using the same mechanism. So that is accounting for the change in potential. Okay.
Okay.
Now it's the assignment number 3. When EIS data from the following circuit is validated using KKT by integration, the transform data did not match well. What could be the possible reason? Large amplitude perturbation was used. So this from assignment 3. I am discussing questions from assignment 3 also today. So large amplitude perturbation was used. Data was transformed in impedance mode. Data was transformed in admittance mode. Frequency range was limited. Who can tell the answer?
Answer is frequency range was limited, but what is the logic behind that? That we don't know.
See, this was already discussed during the assignment 3. So where I said KKT is, what does it do? It tries to fit the data, right? It's trying to fit the data and try to validate it, right? So if you have, so I have to also turn the pages to exactly tell you what was that example. So what was the condition when we are doing KKT? So KKT says you need to have KKT can be done. What is you do? What do you do in the KKT? You're trying to find validate the data, right? To see if it is linear, causal, stable, etc. Okay. So when you are doing KKT transformation for a given set of data, you need to have data from 0 to infinity frequency. If you all remember, this was the first condition that was told. Remember, you need to have the data over the wide range of frequency range. Now what will happen? So if you remember, there was a formula like KKT like transformation. It is based on an integration formula. What the software does. I don't exactly remember the formula, but it was something like integral. It was a lengthy one. So based on that formula, it is trying to validate or try to fit it and tell if it is KKT compliant or not. So for doing that, you need to have a wide set of data from 0 to infinity frequency point. But we also saw a case, if you remember, if we have a data like this, sir had shown in this video, if we have only data up to a limited frequency, it will try to fit the data, okay, for this limited set, and you may get something like this. It may be actually KKT compliant because the data is not available over the entire frequency range. It may say that it's not KKT compliant. So to add one more point to that, so we had also said, so in such a case, either we have to, so what is the way to overcome this issue? Either we have to find it over the entire frequency range, or we should try interpolation and then try to do KKT compliance test. Is it clear?
Yes.
So yes, please go through the previous this thing also. We had discussed this, and I remember someone asking me also a doubt based on this. So if you are doing KKT test, you should have the data over the entire frequency region. Yes, the next question, and it says, if the condition of linearity or stability or causality is violated, then EAS will not be KKT compliant.
It is false.
Why is it false?
It is the condition that it should be, I mean, it should have linearity, stability, and causality. Then only you can follow the, you can accept the KKT. Otherwise, it
Yes.
cannot.
Yes, but here the question is if the condition of linearity or stability or causality, if any one of them is validated, will it say it is KKT compliant or not? Data will not be KKT compliant. So if the system is if system is, that means if the system is non-linear, then the given ES data is KKT non-compliant. If it is not stable, again KKT non-compliant. If it is not causal, again it's not KKT compliant. We have also seen examples where even if the system is linear, is non-linear, it is difficult for KKT to flag it off as KKT non-compliant. So again, to stress, if you go back, we had seen that only if the system is not stable will EIS be able to always say that it is not KKT compliant. So these are only sufficient conditions, not necessary conditions. There are cases where one of it is violated, still EIS data can be flagged off as KKT compliant. So these were taught last time, so the answer is false. Okay. Now, KKT equation relates real and imaginary part of the impedance, magnitude and phase of the impedance, real part of the impedance and admittance, none of the above. What is it?
Real and imaginary part of the impedance. Convert it from real to imaginary, and it can convert from imaginary to real.
Okay. Is it all? Any other? It can also relate the magnitude and phase of the impedance. So please check if it is a multiple select options or single select options. Okay. So if you, I'm not sure if partial marking is there, you may get wrong. Only if you attempt one of the correct answer. Okay. KKT is always sensitive to violations of linearity, stability, both or neither. What is it?
I think it is linearity and stability both.
As I told little earlier, there are cases where the system can be non-linear, but if you do KKT, it can flag it off as KKT compliant when it is actually not supposed to. So if it is not stable, it will surely flag it off as KKT compliant, non-compliant. Like this, it was there in the video. Like sir had explained different examples, if you remember. So where we saw, even if it is non-linear, there are cases where KKT will say yes, it is KKT compliant. So please go through that, and I hope it will be clear. Impedance spectrum from a circuit consisting of passive elements. Is KKT compliant if perturbation is small? Is KKT compliant if multi-sign is applied? Is always KKT compliant? Is never KKT compliant?
What do you mean by passive element? Means what should we understand?
Passive elements means the resistor, capacitor, inductor.
Is always KKT compliant.
Correct. So because KKT is always difficult, that's why we are going with the use of passive elements to model the circuit. So the idea is, if you are using passive elements, it is always KKT compliant. Okay.
Right.
If the potential instability is present, then the effect may manifest mainly in high frequency, low frequency, both, none of the above. So the answer is low frequency. Okay. So all these examples are like some as examples. It is there in source videos. So where we saw that if it is unstable, where we are giving a ramp input, so in that case it will go something like this in the low frequency regime. So it is going in the negative, and which is not actually expected, and we say it is because of the instability which is involved. Okay. Yeah, now the next question is, if real part of the impedance spectrum has negative values, they can be converted to positive values by adding a large enough capacitor in series, adding a large enough resistor in parallel, adding a small enough resistor in series, adding a small enough resistor in parallel.
B option, second.
Huh? I didn't hear you.
Adding a uh, adding a small resistor in parallel, right?
Yes, it is adding a small resistor in parallel. Correct. In measurement model approach, the data can be fit using Maxwell circuit, void circuit, ladder circuit, none of the above. What is it? Who can tell? What are we doing in measurement model approach? We are using passive elements like resistor, capacitor, and inductor. And the question is, how can the data be fitted? Maxwell circuit, void circuit, or ladder circuit? Or none of the above? Any answer?
All of them, Maxwell circuit, void circuit, and ladder
Correct.
circuit.
Correct. It's Maxwell, void, and ladder. If the impedance spectrum is acquired at 3 frequencies per decade, logarithmically spaced, then the following validation technique will not be able, will not be, sorry.
It is suitable. Will not be suitable.
Sorry,
Correct.
okay,
Suitable.
thank you. Will not be suitable, thank you. Is it measurement model approach, linear KKT, direct integration of KKT in impedance mode, direct integration of KKT in admittance mode? Who can answer? So I told you KKT, for doing KKT, you need to have a data from 0 to infinite frequency. That means you need to have a wide set of data. So so if the data is not completely available, what happens? You may get it as KKT non-compliant. So what does it mean? 3 frequency per decade. That means your points are not within each decade. You are having only 3 points. So here you will have 3 points. Now here you will again have 3 points. Okay, again this range also, that is from 10 to 100 you have 3 point, again from 100 to 1000 you have 3 point again. So if you 100 to 1000 you're having only 3 points, again from 1000 to 10,000 you're having only 3 points. So see how much the data is widely spaced. So in such a case, if you do, KKT can say it is non-compliant. So here the answer is KKT model is not suitable. Irrespective of you do it in impedance mode or admittance mode, it will say it is KKT non-compliant. Okay. So that is the answer. So I have discussed assignment 3 and assignment 6 completely. The next day we will do another assignment discussion. Okay.
Still the last question is remain 10th one.
Okay. Is there one
10th
more
one is,
question? Okay. I did not see that question. Can anyone tell me what is the question?
it is that EIS data shown as complex plane plot below was believed to be acquired from a stable system and the perturbation amplitude was small.
Huh.
However, when it was validated with
Huh.
KKT, the
Huh.
transform data did not match impedance data, especially at low frequencies,
Okay.
and the results are shown below. Then they have shown two graphs.
Hmm.
They've plotted three graphs.
Okay.
And the
Yeah. So.
options are
Huh.
the reasons for mismatch is data was acquired in limited frequency range,
Hmm.
then direct integration by KKT was used,
Hmm.
and next one is data was transformed in impedance mode.
Huh.
Last one is none of the above.
So it is the option C is the answer. Okay, that was also when you're getting mirror image, that is because you have acquired it in impedance mode, I remember, but the exact reason I don't actually yeah, because the impedance was in the low frequency regime, your impedance value was going to the negative region, I think, right? I have to check the exact reason. I forgot, but the answer is option C of what you told. Okay, so
Yes.
there, so in such a case, what you have to do is you have to do it in admittance form. Okay,
Yes. The
in
answer
that,
is C.
yeah.
Data
So
was transformed in impedance
okay,
mode.
yeah. So in such a case, you will have to do it in admittance form. So mirror image you are getting. So in order to overcome that, you will have to do it in admittance form. Okay. So now in this week, only two mechanisms were taught, and the third one was like how many potentials you have to take for obtaining the parameters, etc. So that we had already discussed you based on one question in assignment 6. So where I told the number of parameters you get from the fit model should always be greater than the, or equal to that from the mechanism model. So that was the first one. So that part was already is discussed. Now another one, what is taught is one adsorbed intermediate. You're getting negative impedance, and that is a catalytic mechanism. I'll give a small, what to say. I hope everyone is now thorough. Like you are able to do mechanisms on your own. So I'll just give a summary of what is taught, and then we'll stop today's class. So I hope the discussion of the assignment questions were useful for you people. We'll
Yes, it is
side by
very useful.
yeah,
This assignment discussion is
Yes,
very useful
very
because
useful.
yeah, okay. So
numericals we were not able to do all these numericals, how to
okay.
substitute the values and Faraday constant and all these things.
Okay. So so thanks for letting me know your difficulty. So because of that, that's why I shifted. I spend more time on the assignments. So next week onwards, so we'll cover up all the assignments that are pending also. Side by side, I'll do one or two assignments fully every week. So we'll catch it up by the end. Okay. So now just giving a brief, so you have to also prepare for your next week assignment, that is week 7. So I'll just give a brief summary. It should be of the same kind, I think. I did not go through the assignment. So here what you're doing is it's a catalytic mechanism where your adsorbed species is actually acting like a catalyst. It is helping in the, it is catalyzing the reaction. In the second step, if you see, what does M-adsorb do? It will convert the metal M, the species into solution species M solution plus without getting consumed. M adsorbed is not getting consumed here. Instead, it is, so we can say it is just basically catalyzing the reaction. So you get something like this. It is not used up in the reaction, it is just catalyzing the reaction. So the first step is to write the balance of the side balance. Who can tell me? So here the trick is in writing the side balance. Can anyone tell? How is the side balance happening? How many intermediates? Only M adsorbed. Now how will you write? I think this is third week or something where we are doing continuous
Yeah,
mechanisms.
K1 1 minus theta
Huh.
minus
Hmm. Minus?
K minus 1
Hmm.
theta. K minus 1 theta.
Correct. Okay, why not in second step? Again, M adsorbed is involved. Why are we not including that in theta balance?
Because this is same solution, right? So it
So,
is not, electron is not coming.
so in the second step, you can see the M adsorbed is used and again the M adsorbed is formed. There is no change in the site vacancy after second step. So if you see in the first step, forward reaction M adsorbed is formed and in the backward reaction M adsorbed is consumed. While in the the second step, if you see, the M adsorbed is actually facilitating the reaction, but it's not getting consumed or formed or anything. This M adsorbed comes out as such. There is no change in the side balance. Okay, that is why when we are writing the side balance, we are only considering this first reaction. Okay, so this is a mistake that everyone can make. Someone will write K2 into 1 minus theta into theta, but that's not correct. The second step, you see, M adsorbed is used up and that M adsorbed is again formed. I mean, in that reaction, there is no consumption of the M adsorbed happening. So, this is the side balance. Now, if I'm equating it to 0, that is at steady state, you will get theta SS as something like K1 DC. Because of time constraint, I'm not asking. But anyway, such places where everyone can make mistake, I'll ask in particular. K1 DC plus K1 minus 1 DC. So this is how you will get the. Now the next one is, what is Faraday impedance? Faraday current. Ceph into. So all the steps are electron transfer reaction. So it would be nothing but K1 theta, K1 1 minus theta okay, minus k minus 1 theta plus k2 1 minus theta into theta, right? Is this correct?
The second one, K2 multiplied by 1 minus theta and theta both.
Yes. Because m absorbed plus m. M absorbed is theta, m is 1 minus theta. Right? Now,
So theta is for m adsorbed and 1 minus
yes,
theta is for
m,
m
bare metal.
solution.
Yeah. No, m. K2 into,
M.
yeah, m absorbed into m. So concentration, I mean, where m can occupy is theta sides, 1 minus theta, and m absorbed will occupy theta sides. So then when you are substituting, you will get something like IF equal to F into K1 DC 1 plus B1 AC minus theta dash EAC minus theta SS again next term is minus K minus 1 DC 1 plus B minus 1 EAC theta SS plus theta dash EAC. Last term, that is I am expanding K to DC plus B2 1 minus theta SS minus theta dash EAC into theta will be written as theta SS plus theta dash EAC. Now what you will do? You will rearrange the terms. Okay, and you will be removing all those terms which corresponds to IFDC. Okay, and IFAC will be obtained, and then again all those terms where square comes, you will eliminate all those. Okay, if I am doing it, I will get something of the form F. See, please try out the questions, because you see, like, if numerical problems are coming, it is going to be somewhat lengthy. If you're supposed to find out some impedance or charge transfer resistance, polarization resistance, etc., it will be lengthy. So it is better try out the question so that you will have that speed in doing. I hope everyone is trying it out. Okay, you will get something of this form. It's lengthy. This is the equation you will get. Okay, so if you see, you will have to now find out the value for theta dash. This value needs to be found out. So you know how you will do in so you will substitute for d theta by dt as j omega EAC theta dash in equation number 1. In equation 1, which is the equation 1? This one. And then you will cut off all the seconds square terms. You will cut off all the terms where the constants are involved. You will only consider those terms in which EAC is coming as coefficient. Then when you rearrange, you will find out the theta dash value. Okay, where you will get theta dash as something like B1, B minus 1, K minus 1 DC, theta SS, plus K2 DC, plus J omega gamma. Then you will substitute back in this equation and finally you will get the equation for YF. Something, it's a lengthy expression. So again, you may, I'm not sure, I've not gone through, I'm not sure if you have questions based on this equation. 1 minus theta SS, okay, plus K2 DC minus 2K2 DC theta SS minus K minus 1 DC into, you have the theta 1 expression that you got, okay, so this is the final equation that you'll get, okay. So this was what you saw in the last week. Is there any doubt? Have you finished? Is that clear? Do you have any doubt? So this is what we saw in the last class, okay. I'm stopping the presentation, I mean this week. So yeah, anyone has any doubt?
No doubt, ma'am. Actually, I have watched this week uh, lectures. So, sir has not talked about the concentration oscillation, potential oscillation, but we are having one question in assignment.
Simple electron transfer reaction, concentration oscillation and potential oscillation. Like I didn't get you.
One question is there
Okay.
in assignment.
Okay.
So, infinite boundary condition for simple electron transfer reaction. There is, I think, the sir is asking about this concentration oscillation and potential oscillation.
Could you post it in the discussion forum then? So that's
Some
okay, because I've also not checked the assignment. Okay, then we'll get back to you.
okay. Last question is there.
Okay, just post the same question in
DC
discussion forum.
oscillation means out.
Yeah,
Okay,
please
okay, thank
post
you.
it in the discussion forum. Okay, anything else? If nothing, then we'll stop today's class. Okay, thank you everyone.
Okay,
Okay.
thanks, sir.
Yeah,
Okay,
thank you.
thank you.
Thank you.